Welcome back, Leo Lions. This is Mrs. Morgan again with our lesson over squares and square roots. So the first part, we're going to talk about what is squaring a number. Squaring a number is raising that number to a power of 2. For example, 4 squared equals 16. Because 4 times 4 equals 16. So the exponent tells us how many times we are multiplying the base by itself. All right, so for example, we have a big number and then we have an exponent. This is what we call the base. So the big number, we multiply as many times as what the exponent tells us to. All right, exponents only go to what they touch. So for example, when a negative value is squared, we have to be careful on whether the exponent is touching the parentheses or the number. So for example, this negative 2 squared, this means negative 2 times negative 2. I'm going to put this a little smaller, a little more organized. Negative 2 times negative 2. So we'll talk a little bit more about negatives and their properties, but a negative times a negative is a positive. So this will come out to positive 4. Same thing with the negative 3 squared. That means negative 3 times negative 3. So it's going to turn out to a positive. Negative 4 squared. Negative 4 times negative 4, positive 16. Okay, now over here it's different because the exponent is touching the number. It's not touching the parentheses like over here. So over here we were taking what was in the parentheses and multiplying it by itself. Over here what's happening is we have the 2 exponent touching that 2. So that's 2 times 2, and then the negative is out front. So this one is negative 2 times 2. It's going to end up being a negative because a negative times a positive is a negative. Okay, same thing here. This will end up being negative 9 and negative 16 because that exponent is touching the number and not the parentheses. So you really have to be careful and pay attention to what is the exponent touching. Okay, now the opposite of squaring a number is square root. So we call these, taking the square root, is the opposite or the inverse of squaring a number. Okay, so for example, the square root of 16 is both 4 and negative 4 because the square root means what number, and I'm going to write this up above here, what number times itself gives us that number underneath the square root sign. So 4 times 4 is 16, but then also negative 4 times negative 4 is 16. So 4 squared is 16, but then also what we just looked at up there, the parentheses of negative 4 squared is also 16. So the square root of 16 can be both the positive and negative version of 4. However, what we're going to be looking at, if we see a square root sign, we're always going to assume that that's the positive square root and what we also call the principal square root. So when we're using that square root sign, the solution is going to be the positive square root. Okay, so we call 16 a perfect square root because it comes out to a perfect whole number. A lot of square roots don't come out to a whole number. They come out to this big, long decimal, and that's not called a perfect square root. We want it to come out to a whole number in order to be perfect. Okay, so down here at the bottom, I already filled this out and you guys can copy it over into your notes. These are all the perfect squares and perfect square roots. So 1 times 1 is 1, 2 times 2 is 4, and so on. And I made this big long list. It's very nice to have this list handy as we're working with square roots and squares. And then the opposite of those, so let's take, for instance, down here, the square root of 81. Well, what number times itself gives us 81? And that's 9. Okay, so I have that big long list there, and you can always pause the video and write down all of those into your notes. Okay, let's go to the second page and actually do some evaluations with these square roots. So evaluate, if we do not know this word here, means the same thing as solve the following squares and square roots. So -7 squared, what that means is -7 times -7. 7 times 7 is 49, and a negative times a negative is a positive. So that is our final answer. All right, 2/3 squared, the next one. So what this means is 2/3 times 2/3. So multiplying fractions, we just multiply straight across. 2 times 2 is 4, and 3 times 3 is 9. So we have 4/9. When we're squaring a fraction, we can just square both the numerator and denominator separately, and that's our solution. Okay, here's that example we were talking about on the last page. So this is 9 times 9, since that square, that exponent is touching just the 9, and then the negative is out front of it. So a negative times a positive, we're going to get a negative. 9 times 9 is 81. Okay, now let's look at some square roots. So the square root of 196, if we go to the first page, that was down here. Square root of 196 is 14, but notice on that example there is a negative sign out front. So the negative will stay in our answer, and then square root of 196 is 14. All right, number 5, decimals. If it is a decimal with a perfect square root, so we know the square root of 81, well, what number times itself as 81 is 9 times 9. So when we take that out, we're going to get 9, and then there's a decimal in front, so add that decimal. Okay, we could always come over, check our work, and do 0.9 times 0.9. Well, 9 times 9 is 81. With decimals in a multiplication problem, we have 1, 2, so we'd have to move that decimal 2 places, and notice it takes us right back to what we started with. So we know 0.9 is the correct answer. Okay, square root of 9/16. We can separate these, and we can do the square root of 9 over the square root of 16. So square root of 9, what times what? What times itself gives us 9 is 3. What times itself gives us 16? Well, we did that on the other side, is 4. So our answer is 3/4. Okay, let's keep going then. We get a little farther here. If there's a number in front of a square root like this means 2 times the square root of 64. So anything squeezed up right next to each other, that means multiply. So this is going to be 2 times the square root of 64 is 8. Now I have all of these memorized. I know them pretty well. If you need help, obviously remember they're all on that front page. You're thinking about what number times itself gives us 64. So 2 times 8 is 16, and that's our final solution. All right, next one, 5 plus the square root of 121. So 5 plus 11 times 11 gives us 121. So 5 plus 11 is 16. All right. Again, this -3 is touching that square root of 225. So I'm going to do -3 times 15, because 15 times 15 gives us 225. And then -3 times 15 is -45. Negative times a positive is a negative. And then -45 plus 10 is -35. All right. Next one, we want to do both these square roots. So the square root of 144 is 12 minus the square root of 36 is 6. 12 minus 6 is 6. All right. Next one, so we'll do 15 times the square root of 16 is 4. 15 times 4 is 60. Okay, obviously a lot of these I'm going through quickly because I know these. If you don't know 15 times 4, well then you just have to write it off to the side here and figure that out. 5 times 4 is 20. 4 times 1, add your 2, and there you go. Okay. Negative is out front of the square root, so negative, the square root of 81 is 9. -9 plus 20. Those are opposite signs, so we end up subtracting them because we're starting at -9. We have to go 9 to get to 0 and then keep moving up. So we'd subtract them, which is 11, and we keep the sign of that bigger number. 20 was bigger, so it stays positive. Okay? Some story problems here. A group of 225 students need to be arranged in a square formation for a halftime performance show. So we want a perfect square with all of these students. Remember, a square has all the same side measurements. So we want to figure out what times what gives us a total of 225 students in there. So to do that, what times what we're doing is the square root of 225. And the square root is 15. So we'd want 15 students arranged by 15 students, and that would give us 225 total students. Okay? Ivan's room is a square, so we're dealing with a square again. All sides are the same. Okay, with an area, we know that the area, and I'm going to kind of, all of this space in there, that is 144 square feet. So what is the perimeter? Remember, perimeter equals all sides added. So we first have to figure out what is this side measurement, and then we have to take that side measurement and add them and do x plus x plus x plus x. Okay, so we're trying to figure out that x. Well, if it's a square and we know the area is 144, well, we're trying to figure out what times what gives us that 144. Again, that's our square root. So the square root of 144 is 12. So we know this side length is 12. So if all of them are 12, we'd want to do 12 plus 12 plus 12 plus 12. Or a quicker way to this would be 12 times 4. You're going to get the same thing, okay? So 4 12s gives us a perimeter of 48 feet in his room, okay? Make sure you get all of those notes copied down, and we will continue working with squares and square roots.